All right, so here's the second part of your notes on 2.3 talking about scatter plots, okay? So scatter plots show the relationship between two variables, and oftentimes when we see scatter plots, they are just kind of like a series of points on a graph. So let's draw some examples of these. There are three different types of correlations: a positive correlation, negative correlation, and no correlation, okay? So correlation means it's talking about like the relationship between the x and y values. So a positive correlation is going to look a lot like a line with a positive slope. A negative correlation is going to look a lot like a line with a negative slope, and then no correlation is not even going to look like a line at all. So let's sketch out some of these really quickly. So if we had a graph like this, positive correlation, we have a bunch of points here, and you can see it's pretty much like a line with a positive slope. If we look at a negative correlation, we can have axes like this. These points will look like they're kind of in a negative line like that. Okay, so positive correlation, negative correlation. And then no correlation is going to look like, it's not going to look like a line at all. So basically we're just going to have a bunch of points out here. They don't really like form anything that looks like a line. Okay, so when we talk about the line of best fit, given a positive or negative correlation, so there has to be a correlation, it's possible to write the prediction equation called the line of best fit. It can be used to predict the value of a variable given the value of the other variable. So basically, we're going to use this correlation and draw a line, give a linear function that kind of represents the pattern of the scatter plot. And then we can use that line and that equation to predict what another point might look like. Okay, so this is scatter plots it's real data that we're plotting here, and then we can make our own guess using line of best fit. Okay, so we have a table over here to the left. So the table to the left shows a relationship between the depth d of the lake. So it looks like d is over here, which is generally our independent variable. So I'm just going to go ahead and label the graph now. D is depth of a lake. And in feet, it's important to note the units there. And the water temperature T in degrees Fahrenheit. So T is our Y value here. So I'm going to just write this temp in degrees Fahrenheit. So I'm just labeling the graph so that it's easier for us to kind of tell what this is supposed to look like. Okay, so A says make a scatter plot. So here we're just going to plot all of these points here. So from 0 to 15, let's do 2, 4, 6, 10, 12, 14. Just labeling, it should be 22. 26. That should be plenty. 15 is only about halfway through there. Okay, and then the temp goes from 76 to 85. So what I'm going to do here on this line is I'm going to make one of these things, and that just means that there's a bunch of numbers that I'm omitting here. So I want to start this at like 70 here, and then let's see, 1, 2, and then 80, 2, 4, 6, 8, 90. That should be good. Okay, so what this means is I'm counting every grid here as 2. This is 2 more. But because I don't want to start at 0 and go all the way up to 70 by 2, I just make this little mark down here to say that we're just going to start basically at 66. Okay, so now I can graph these. So 0, depth of 0 is 85 degrees, so 2, 4, 5. Depth of 4, it's 82. 82. 7 is 81, so 7 is right here, kind of in the middle there. 10, 79, 12, 70, that's 78, 77, 15, and 72, 4, 6. Okay, so I just plotted all these lines in orange, each of these points here. So make a scatter plot, got it. Use two ordered pairs to write a line of best fit. Okay, so basically what I want to do is I want to find two points that are kind of going to represent like the center, that I can connect to make a line that will go through kind of the center of these scatter point plots. Or, I'm sorry, these points. So what I'm going to do is I'm going to pick the first and the last one, and I'm going to use them to draw a straight line like this. Okay, so I drew a straight line there. And I want the equation for this line. So this line looks pretty good. It hits 1, 2, 3, 4 of these, and the other two are very close. So I want to use these two ordered pairs that I chose to make a line. So I chose the first and the last ones, which are 0 and 85. We'll use this as our x1, y1, and the last one is 15 and 76. That'll be our x2 and y2 here. Okay, so we know how to write write the equation of a line given 2 points. So we need to first find the slope. So that's y2 minus y1. That looks really sloppy. y2 minus y1 over x2 minus x1. So filling these in, we have 76 minus 0. I'm sorry, 76 minus 85 over 15 minus 0. 76 minus 85, that's going to give us negative 11, I believe. I'm sorry, negative 9. Negative 9 over 15 minus 0 is 15. So this is negative, which we expected because our slope is negative here. And then it looks like we can reduce these. We can divide each by 3. So this will be negative 3/5 is our slope. And then we can write it using our point slope formula. So y minus y1 is equal to m times x minus x1. I'm just going to pick the first point because that's easiest. So y minus 85 is equal to negative 3/5 times x minus 0. And then we can just write it in slope-intercept form by simplifying. So x minus 0 is just x. So we have y minus 85 is equal to negative 3/5 x, and then we'll add 85. So y is equal to negative 3/5 x plus 85. This is the equation to the line. So predict the temperature of the lake at 25 feet. So we're given 25 feet is the depth. So D is equal to 25. And we already said that D was our x value, so we're going to plug in. So what does y equal when x is equal to 25? Well, the equation is y equals negative 3/5 x plus 85. So let's plug in 25 for x. We get y is equal to negative 3/5 times 25 plus 85. So just coming right back up here, y is equal to, let's see, negative 3/5 times 25 is negative 15 plus 85. I want to say that's going to be 70. And it is. So y is equal to 70. Well, y we said was our temperature in degrees Fahrenheit. So this means at 25 feet, we get 70 degrees Fahrenheit. That's our prediction based on these other values that we got in the trend. Okay? So now let's look at linear regression. Another method to find the line of best fit is called linear regression. This can be done through your graphing calculator and will create the most precise equation possible. Okay, so the graphing calculator is able to take all of the points that you put in and use that to kind kind of use every single point to make a line of best fit, give you an equation, okay? So here is how you enter your data. So you'll enter your scatter points like this, and then this is how you find the line of best fit. So this is using the TI-84, which are the calculators that we have in the classroom that look like this. However, I'm going to do a video of how to use an online version of this, and then we'll also use these in class. So you'll have one you can use when you're at home and you don't have access to a graphing calculator, and then we'll also show you how to do it in class. Okay, so I am just going to I'm just going to post the solutions to this one here.